Hi, this is Mrs. Blake, and today we're going to talk about solution calculations. With solution calculations, there are a number of different calculations that can be done, and today we're going to talk about percent by mass. But first, I want to talk about a unit or a term that's commonly used, and that term that's commonly used is the term concentration. And concentration is the amount of solute divided by the amount of solution. But if I take a look in terms of calculations, solute can be measured in a number of different ways, and so can your solution. And that leads to a number of different calculations. So we're going to be focusing on percent by mass today. And percent by mass today takes a look at the mass of the solute divided by the mass of the solution, and you take it times 100. Closely related to percent by mass are concepts known as parts per million and parts per billion. And the difference between parts per million and parts per billion in percent is the number of parts that they are. Percent is parts out of 100. So if I have 3%, it means 3 parts out of 100. If I am taking a look at parts per million and I have 3, that means I have 3 in a million, and same for 3 in a billion. So when we have really, really small concentrations, like hopefully the amount of lead in your drinking water, you don't want to measure lead in your drinking water in percent. You want to have such small quantities that we're going to use parts per million or parts per billion, because that makes it that much safer, because there's that little amount of solute in your solution. We also can take a look at percent by volume. Percent by volume is a very similar calculation, except for I have a volume of my solute, and I am going to divide it by the volume of my solution before I take it times 100. So almost the exact same calculation for all 4 of these, except for I'm either multiplying it by something different, or in this case, percent by volume, I'm measuring my solute in volume rather than measuring it in grams. Molarity and molality are very similar related concentration units. Molarity is the moles of solute divided by liters of solution, and molality is the moles of solute divided by the kilograms of solution. We also could take a look at concentration in terms of density, and we could take a look at concentration in terms of mole fractions. But in reality, when we're taking a look at anything, this is a units thing. And with solution calculations, it is incredibly important that you are being very, very careful to read your problems carefully. So let's take a look at the concept of percent by mass. And what is percent by mass? It is the mass of your solute, usually measured in grams, divided by the mass of your solution, also measured in grams. And I take it times 100, and that means that my units will cancel out, and I'll just have a percent sign. One key term that you need to make sure that you're aware of is when we talk about solution. Solution is not just water. Solution is the amount of solute and the amount of solvent. If I'm taking a look at my total solution and I'm making a saltwater solution, 50 grams of water that gets 10 grams of salt added to it, the mass of my solution is 60. So it's going to be really important to read your problems carefully. Do they tell you that the mass of the solution is something? Or do they tell you that the mass of your water is something? Because if they tell me just water, I have to make my solution myself by adding my solute plus my solvent. So it's going to be really important that you're reading these problems very carefully. So let's take a look at a couple of examples of problems. And the first problem says to calculate the mass percent. So I'm using this calculation of sodium sulfate solution when I have 15 grams of KNO3 is dissolved in 250 grams of water. So again, when I'm reading this, here is 15 grams of my KNO3. That is going to be my solute. That's what I'm dissolving. And I am going to dissolve it into 250 grams of water. What's my problem? Well, that's not solution. So I have to remember that solution is going to be my solute, which is going to be this 15.0 grams. And I'm going to add it to my water so that when I'm actually making it my solution is going to be 265 grams of solution. So if I'm going to look at percent by mass, I am going to take this 15 grams of what I am dissolving, which is my solute, and I am going to divide it by this 265 grams, which is the mass of the solution that I'm making. And then it is a percent. And if it is a percent, I am going to take it times 100. So in my calculator, I am going to take 15. I am going to divide it by this 265. I'm going to take it times 100. And my calculator is going to spit out a 5.6%. So it is going to be really important that when you read your questions, you have to clarify, do they give you 250 grams of solution? Or do they give you 250 grams of water that you have to add your solute to? So let's take a look at the second problem. And the second problem has a couple of things that we need to pay attention to, but let's take a look at it. Calculate the mass percent of potassium nitrate in a solution when 50 grams of KNO3 is dissolved in 250 milliliters of water. Now, if I'm taking a look at my percent by mass, milliliters is not a mass. Milliliters is a volume. So not only do I have to pay attention to the fact that is this solution or is this solute or is this just water, I also have to pay attention to the fact that this is going to be milliliters. No, my solution is not in or my solute is not in milliliters, so I can't do a percent by volume. So I have a conversion, and this is not a hard conversion. I know that 250 milliliters of water, where 1 milliliter is equal to 1 gram, means that I really have 250 grams of water. Second thing I need to pay attention to then is this is water. So to make my solution is made up of water and whatever I'm putting into it. So I have 250 grams of water, and I'm going to add 50.0 grams of this KNO3. So that when I take a look at my percent by mass, this is going to be the 200 or the 50 grams on top divided by the 300 grams on the bottom, and I take that times 100, and this is going to come out to be 16.7% when I put this into my calculator. Last type of problem we're going to take a look at today is a little bit rearranged. This time, I am supposed to be calculating the mass of sugar needed to make 250 grams of a 6.5% solution. So this time, they are going to give me my percent. I'm not finding percent. This time, what I'm trying to find is the mass of the sugar. So in other words, I'm trying to find the mass of the solute instead of finding the percent. So in this problem, they give me that there is going to be 6.5%. And they tell me I have 750 grams of a 6.5% solution. So I don't have to worry about this being water and something else. They give me the mass of my solution here. And the mass of my solution is going to be 750 grams. And this time what I'm trying to find is going to be the mass of my solute. Well, in this case, we've got to algebraically rearrange the equation. And I know anything on the bottom of an equation moves to the top when you switch it on sides of the equal sign. So I am going to rearrange this equation, and I am going to have this mass of my solution on top. And it is going to be times my percent by mass. And then I've got this times 100. And the important part to consider with this is, how are you doing your percent? Mathematically, and I know mathematically there were worksheets you did in probably elementary school and middle school where you took percents and turned them into decimals by dividing by 100. And that's exactly what you need to do with this equation. So while I have a 6.5%, I need to divide that by 100 to turn it into a decimal. So this is going to be 0.065 before I take it times the mass of my solution, which is going to be 750 grams. So if I take 0.065 times 750, I'm going to come out with 48.75 grams of sugar that I need to be able to make this solution. With any solution calculation, it is going to be incredibly important that you read the question carefully. When working with percent by mass, we are going to take the mass of the solute, divide it by the mass of the solution. But again, what I need to be really careful of is water is not solution. Water is solution and any solute you put into it. And so do they give me the mass of the solution, or do I need to come up with that mass of solution like we had to do in the first couple of problems? All right, thanks for watching.